Section 5.6, laws of logarithms. So the laws of logarithms are similar to your rules of exponents, meaning, look at what we have here. We have a log base b of m times n, and when we're multiplying expressions, look at how we expand it. We use addition. Okay, so multiplication and addition are generally paired together. When I'm dividing expressions, how do I expand that? I expand that by using subtraction. Log base b of m equals log base b of n, if and only if m equals n. All right, well, think about all those expressions that we solved. If I had 2 to the x power equals 2 to the 5x minus 1, how do we go about solving this? Well, when the bases were the same, we were able to set our exponents equal to each other, and we could solve from there. Log base b of m raised to the k power. This is an extremely important rule, and you will use it constantly. This is what we call our casting rule. So that exponent can be brought out front of the logarithm, and now I have k times log base b of m. All right, and k is a real number. All right, so for these two, the first two at least, this is what we would call our condensed form. And then on the right-hand side, this would be our expanded form. So we'll do examples today of going between both. Expanding a logarithm using the rules or condensing a logarithm using the rules. Okay, applying the laws. So last lesson, we learned how to evaluate this. So 3 raised to what power would give me 1 over 27? Well, 3 to the third power is 27, and then because I have a whole number to a fraction, I know my exponent needs to be negative. Now let's prove this answer using the laws. Okay, so I have it in this form, log base b, and I'm dividing an expression. How do I expand that? Log base 3 of the numerator minus log base 3 of the denominator. Okay, that's my rule. This 3 raised to what power would give me 1? That's 0. And then here, 3 raised to what power would give me 27? That's 3. So it verifies my answer that we were already able to evaluate. Okay, now this one is in expanded form. So if I look at this in expanded form, then to condense means I'm only allowed to write one logarithm. These are attached with a plus sign, so when I put them together, I use multiplication. All right, so I get log base 10, and what's log base 10? This would evaluate to 1, so that would be your final answer. Okay, and why? Because 10 raised to the first power would give me 10. All right, 1/3 log of 64 plus 2 log of 5. So I'm going to condense both 3 and 4. I have a real number out front, so that number becomes the exponent on my base, and I'm going to use that rule on both expressions. Okay, I'm condensing. To condense means to write with a single log, so I'm only allowed to write log one time. So this one becomes 64 to the 1/3 power. My plus sign, I condense that using multiplication of 5 to the second power. Okay, log. The cube root of 64 is 4. 5 squared is 25. So I have the log of 100. And now the log of 100, to evaluate this, 10 raised to what power would give me 100? So my answer is 2. So in expanded form, we can't simplify. We can't evaluate this at all. But when we condense it, we can in fact find an answer. All right, notice here we have subtraction and addition. So I'm going to use multiplication and division. Oop. All right, sorry about that. So to condense, to write as a single logarithm. 3, the number before my minus sign is always my numerator. Whatever follows the minus sign is going to be in my denominator. So now my denominator, I'm going to multiply 6 times 5, okay? Because the plus sign tells me to multiply the expressions. So this becomes the log of 3 over 30. 3 over 30 reduces to 1/10. So evaluating this, 10 raised to what power would give me 1/10? So this will evaluate to -1. So again, using the rules will simplify an expression for you and allow you to, in fact, find an answer. These would be part of your 9-calculator assessment. All right, now write an expression of separate logarithms. So now we're expanding. And when you first look at these, you really got to key in on how many pieces are there. There's a 2, there's an x, and there's a z. If I have 3 parts in my expression, I'm going to have 3 logarithms written. So I have the log of 2. That's one expression. The 2 and the x cubed are being multiplied. I expand multiplication using addition. So that'll become log of x cubed. Next, I have a term in the denominator. So denominator is expanded using a minus sign. So I have log of z to the 5th power. Now, the only other thing we can do is that all-important casting rule. I'm going to bring my exponent out front. So now my final answer would be log of 2 plus 3 times the log of x minus 5 times the log of z. And for expanding, there's nothing more you can do to the answer. Okay, this one we sort of used this on the previous slide to evaluate. Real number becomes my exponent. So wherever I see that, that's going to become my exponent. I have a minus sign and a plus sign, so I know my answer is going to be a fraction. My denominator is going to include multiplication because that's in the set of parentheses. So a single log, I'm only going to write the log one time. My numerator is a cubed, and I'm dividing that by b squared times c to the 6th power. All right, so now we can use our properties to solve equations. Always condense first. Always, 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 always. So on my left-hand side, I have 2 logarithms. So I'm going to condense that to log base 2, right? That's my common base. They're separated with a plus sign, so I condense them using multiplication. Now I can use my rule if I have log base b on the left-hand side equal to log base b on the right-hand side, then that's true if and only if my expressions are equal to each other. Okay, so I have x squared minus 2x equals 3. This is a quadratic equation. We've literally spent chapters solving this. Get the equation equal to 0. Solve this using factoring. -3, +1. -3 times 1 is -3. -3 plus 1 is -2. So mathematically, algebraically, my solutions are 3 and -1. We have to remember, however, the domain of the logarithmic function. The domain is that all my values x have to be greater than 0. Now, what that means when I go and I do a quick check back into my expression, if I plug -1 in for x here, it would give me a non-real solution. So this is what we call an extraneous solution. If I were to plug 3 into both of where I see x in my original, log base 2 of 3, that's a real number. 3 minus 2 is 1, so that'll give me a real number. So my only solution there is x equals 3. All right, log of x equals an expanded log on the right-hand side. So first rule, real numbers become exponents. So I have log of x equals, I'm going to condense this into a single logarithm. These logs are separated with a plus sign, so I condense them using multiplication. And I have a squared times b cubed. So if I'm solving this for x, as the directions say, I can just, because the bases of the log are the same, the expressions have to be equal. So x is in terms of a and b. Okay, so in addition to the video, complete these problems as well. Okay, they are using the properties, and that's what we'll start class with.